Now we're going to look at what are called the power-reducing formulas, which are essentially rearrangements of the double angle formulas where instead of trying to find something in terms of squares to get rid of a multiple of an angle, we find something in terms of multiples of angles to get rid of squares. So we have that sine squared is equal to 1 minus cosine of 2 theta over 2. Cosine squared is equal to 1 plus cosine of 2 theta over 2. And tangent squared is just sine squared over cosine squared, which in this case can be written as 1 minus cosine 2 theta over 1 plus cosine of 2 theta. So sometimes we have things in terms of powers that we don't want to have to deal with for whatever potential reason. And for one example of what we can do with this, we can see how to express cosine to the fourth of theta in terms of equivalent trig functions without using exponents. So for this, we're going to use our power-reducing formulas, starting with the idea that cosine to the fourth of theta is cosine squared of theta times cosine squared of theta. And as a result, we can then take those pieces there, we can take those two cosine squareds and write those in terms of 1 plus cosine of 2 theta over 2 twice, which we can then take those and multiply them together to get 1 plus cosine of 2 theta plus cosine squared of 2 theta all over 4. Great. We got rid of one power, added a bunch of terms, and now the smaller power. But even though we have cosine squared of 2 theta, we can still break that up again in terms of the power-reducing formula, where we can take the rest of our pieces, we can take that 1 plus cosine 2 theta over 4, and then pull out a 1/4 as well, and we'd be left with cosine squared of 2 theta, which we can write as 1 plus cosine of 4 theta over 2. And from there, actually, we're done, but we want to simplify this. We want to bring our pieces together into something a little nicer. We can split things up and write it as 1/4 plus cosine of 2 theta over 2 plus 1/8 plus cosine of 4 theta over 8, or rearranging, sticking together, cosine of 2 theta over 2 plus 3/8 plus cosine of 4 theta over 8. Essentially, we just take our pieces and rearrange them and turn that cosine to the fourth into a whole mess of things that don't have exponents in them. Why do we need this? Well, you'll see reasons for that when you get further into calculus, but the story is that occasionally these exponents can be harder to deal with than just having those multiples, for reasons that you'll see when you get to work with the integrals. That's about a year away for many of you. In any case, what we'll finish this section with is a look at the half-angle formulas.